to the second part of the parabola video. So right now we'll be doing some practice problems. So I went ahead and did it beforehand so that we can save time and speed it up. So we're gonna be doing question 6. So 6.1 says determine the coordinates of P. Right. So we can already see here. You can see that P is a point of intersection for f of x and for g of x. Okay, so on our statement there, it says f of x is equal to ax squared plus bx plus c. So we don't have much there, but g of x is equal to x plus 4. So we can get the x-intercept from g of x because we have enough info there. So what do we do to find the x-intercept? Well, we let y equal to 0. So g of x is equal, okay, so g of x is equal to x plus 4 is the equation that we'll be using. Okay, so we let y equal to 0 there. We let y equal 0. So 0 is equal to x plus 4, x is equal to negative 4. Therefore, those are the coordinates of P. P is negative 4 is to 0. So the x is negative 4 for P and y is 0. Because right there, at the point of intersection, it's at 0. Y is at 0 right there. Alright, let's move on. 6.2 says, hence or otherwise write down the coordinates of Q. The coordinates of Q will simply be negative 4 divided by negative 2. Negative 2 because Q is on the positive side of the x-axis. Q is on the positive side of the x-axis, hence why it's divided by negative 2. So Q is 2 is to 0. Then we move on. 6.3 says, calculate the average gradient, the average gradient between P and R. So P, we have the coordinates of P and we have the coordinates of R. So now we can calculate using the gradient formula, which is m is equal to y2 minus y1 over x2 minus x1. But I used the letters of our points here, P and R. So I said average gradient is equal to yr minus yp over xr minus xp, which is equal to 9 minus 0 minus 1 minus negative 4, which will give you 3. So we're done with that question. Let's move on to 6.4. Now 6.4 is kind of long, but it's not complicated. It's kind of long, but it's not complicated. You can make it shorter once you understand what's going on. But this is what I have. Okay. So 6.4 says show that for f, a is equal to negative 1, b is equal to negative 2, and c is equal to 8. Now remember what I said, what I showed on the previous video, how to find the equations of the parabola. Well, this is going to apply here because in our statement we do not have the equation of the parabola. So in order for us to show that a is equal to negative 1, b is equal to negative 2, and c is equal to 8, we have to find the equation, because that's the only way we're going to find out. So now when we look at our graph, we have the turning point and we have another point, which is the x-intercept. So what does that mean for us? Well, this looks to me like turning point and another point, which means we can use the turning point form of the parabola to find the equation. So first of all, you're going to write your equation. Y is equal to a bracket x plus p squared plus q. Then you sub the turning point, which is negative 1 is to 9. That's at R. Then we will have the following: y is equal to a bracket x plus 1 squared plus 9. Then we sub negative 4 is to 0 into this equation right there. Then we will have 0 is equal to a brackets negative 4 plus 1 squared plus 9. Take 9 to the other side, it becomes negative. Then we simplify this. Then we'll be left with 9a this side. We divide both sides by 9. Therefore, a will be equal to negative 1. So there we found it. The first one that we found, a is equal to negative 1. Now we're not done because we only found a. We need to find the rest. In order to find the rest, we'll have to put the equation in standard form, because that's the only way of finding out we are finding b and c in the standard form: ax squared plus bx plus c, standard form of the quadratic function. Now listen here, okay, this will be your equation. So we took that a, we put it there. We have y is equal to -1, then x plus 1, this is the turning point, x plus 1 squared plus 9. So now all you do here, now you simplify, distribute whatever needs to be distributed between these brackets, then you multiply this into the bracket only, not to the 9 but only to the bracket, and then you're left with this. And then you simplify further. -1 plus 9 gives you 8. So we will have y is equal to -x squared minus 2x plus 8. Like I said before, like I found before, in fact, a is equal to -1. That's the first one. Then here b is equal to -2. This is b. Then this is c. Okay. The reason why I know that this is b, this is c, is because now our equation is in standard quadratic form, which is ax squared plus bx plus c. Don't forget this, because this is very important. You see, c, that's 8 there, b, that's 2 there, -2, then a, that's -1 right there. Okay, let's move on. Let's move on to the next question. Now we have 6.5. 6.5 says, calculate the coordinates of S, the point of intersection of F and G. Aha! Remember what I said about the points of intersection? This is where both of the graphs are equal to each other. So now, where both of the graphs are equal to each other, we equate the two equations of the graphs. So like I did here, I said f of x is equal to g of x. Then I took the equation of f of x, which we found previously on 6.4. -x squared minus 2x plus 8 is equal to g of x, which is x plus 4. Then we take x plus 4 to the other side. This leaves 0 this side. Then we pair up like terms. Then we simplify them like terms. Then we're left with this. You can divide both sides by negative in order to be left with a positive x squared if you want, or if you're comfortable with doing it without dividing by -1, you can do so too. Now, after doing so, you'll be left with x squared plus 3x minus 4 is equal to 0, and the factors x plus 4 times x minus 1 is equal to 0, x is equal to -4, or x is equal to -1. Now notice that I said x is not equal to -4. Well, that's because s is found on the positive side of the x-axis, so it cannot be negative. So x can only be equal to 1 for s. And then we sub that x is equal to 1 into g of x. Okay, so where there's x, we substitute this x is equal to 1. I was supposed to say 1 here instead of x, but it's okay. You can also do it this way. You won't be penalized for doing so. So g of x is equal to 1 plus 4, which is equal to 5. Therefore s is 1:5. So if you wanted, you could have subbed the x is equal to 1 into the f of x, but I found that to be a longer process, which is why I chose to sub into this one, which is less complicated than the quadratic one. Now here we move on now. 6.6 says determine the maximum length of TV between the points P and S. The points P and S, between the points P and S, okay? Now points P and S, T lies on f of x and V lies on G of x. What does that tell us? Well, since this is a vertical distance, then we will say yt minus yv. So which means that length of TV is equal to yt minus yv. Then we take the y of t and the y of v. Y of t and y of v is the equation of that graph. Remember we said y is the same of g of x or f of x, so that's what we did here. So negative x squared minus 2x plus 8, that's the equation for f of x, minus x plus 4, that's the equation for g of x, because that's where v lies on. Then we simplify till we have a simple equation right there. Then we use x is equal to negative b over 2a to find the turning point, the x value of the turning point, because that's where the maximum value is found. It's found at this point. Okay, so we use this x is equal to negative b over 2a to find the x value of the turning point. Then we sub that negative 3 over 2 into the equation, this equation over there. Then if we do so, we'll be left with y is equal to minus negative 3 over 2 squared minus 3 negative 3 over 2 plus 4, which is equal to 25 over 4, which is the same as 6.25 units. Since we wanted the y, we don't care about the x, because we want the y, the distance, the vertical distance, which is y. So we found y to be the maximum length of TV, which is equal to 6.25 units or 25 over 4.